Hi everybody, let's begin the discussion over the questions on binomial expansion. First question says that find the number of terms in the expansion of this particular expression. So you are given 1 plus 2x plus x square whole to the power 20. That's what we have. We know that in the expansion of x plus y whole to the power n, there are n plus 1 terms. Why? Because if I talk about x plus y whole to the power n, binomial theorem, we know that it is equal to NCR x to the power n minus r y to the power r, where r varies from 0 to n. If r is varying from 0 to n, that means r is actually taking up n plus 1 values. From 1 to n there are n values, and corresponding to 0 there is additional 1 value, so there are n plus 1 values which r is taking. Corresponding to each value of r there is a term which is being obtained over here. That means in this expansion there are n plus 1 terms. So here this is sum of n plus 1 terms. Express this in the form of x plus y whole to the power n. How will you do that? 1, or I should say x square plus 2x plus 1 is actually x plus 1 whole square. So this is what you have. That means you have x plus 1 whole to the power 40. Now it is expressed in the form of x plus y whole to the power n, where y is 1, and therefore this has n plus 1, that is 40 plus 1, that is 41 terms. So in the expansion of x plus 1 whole to the power 40, which is same as the expansion of 1 plus 2x plus x square whole to the power 20, there are 41 terms. Many students commit this mistake of writing 21 terms by just watching out at the power and adding 1 to it. But actually you need to see this expression should be in the standard form of x plus y then raised to the power n. So you convert it in the form of x plus y raised to the power n, and with this n you add 1 and declare that to be the number of terms in its expansion. Next question says that find a if the 17th and 18th term in this expansion are equal. Now the expansion is given of 2 plus a whole to the power 50. 17th term and 18th term are equal. I know TR plus 1. R plus 1th term in the expansion of 2 plus a whole to the power 50 would be 50 CR 2 to the power 50 minus r a to the power r. Fine. So T17 would be T16 plus 1, and this would be T17 plus 1. R is 16, R is 17. T16 plus 1 is 50 C16 2 to the power 50 minus 16 a to the power 16. This is what 50 C17 2 to the power 50 minus 17 a to the power 17. So here you have 50 C16 upon 50 C17 into 2 to the power 50 minus 16 is 34, 50 minus 17 is 33. This is a to the power 17 upon a to the power 16, which is a to the power 17 minus 16, that is a to the power 1, which is a. From here you are just left with 1, 2, and this gives you what? 50 factorial upon 16 factorial into 50 minus 16, that is 34 factorial, and then you have upon 50 C17, so that is upon 50 factorial upon 17 factorial into 50 minus 17 factorial. So this cancels out. 17 factorial can be written as 17 into 16 factorial. This is 33 factorial. In the denominator you have 16 factorial. 34 factorial can be written as 34 into 33 factorial, and into 2 you have. 33 factorial cancels out, this cancels out, 17 ones are 17, 17 twos are 34, this 2 cancels out. You have 1 as your answer, as the very value of a, right? This upon this into 2 is equal to a. This upon this into 2 is coming out to be 1, which is actually equal to a. So your a is 1 if the 17th and 18th term of this expansion are equal. Next we have find the middle term in this expansion. Now the moment you talk about the middle term, you need to talk about the index that is sitting over there. Over here you can see in this expansion the index is 20, which is even. So as or let me first write what is the concept. When n is even, then n by 2 plus 1th term is equal to the middle term. Over here 20 is the index which is even. Here 20 is even. Therefore 20 by 2 plus 1th term, that is what? 20 by 2 is 10, 10 plus 1 is 11. So 11th term is the middle term. Fine. 11th term is the middle term. 11th term I need to find. I need to find the middle term. 11th term can be written as 10 plus 1. 20c10 x to the power 10 or x to the power 20 minus 10 y to the power 10. What is x? X is 2 by 3 x squared. This is the first term, and minus 3 by 2x is the next term. So 2 by 3 x squared, 2 by 3 x squared to the power 20 minus 10, and then you have minus 3 by 2x to the power 10. Right? This is what? 20c10 2 to the power 10 upon 3 to the power 10 x to the power 2 into 10, that is 20. Minus 1 to the power 10 is 1 only. This is 3 to the power 10 upon 2 to the power 10. This is x to the power 10. 3 to the power 10 cancels out. This cancels out. You are left with 20c10 into x to the power 10. This happens to be your 11th term in the expansion of this particular expression. Clear? And this 11th term is actually your middle term. Moving to the next, we have write down the binomial expansion of 1 plus x whole to the power n plus 1 when x is equal to 8, and deduce that this expression is divisible by 64. How are you going to do that? First of all, 1 plus x to the power n plus 1. I know that 1 plus x whole to the power n is nc0 plus nc1x plus nc2x square plus nc3x cube plus and so on ncn x to the power n. Therefore, 1 plus x whole to the power n plus 1 will be n plus 1 c0 plus n plus 1 c1 into x plus n plus 1 c2 into x square plus n plus 1 c3 into x cube plus and so on plus n plus 1 c n plus 1 x to the power n plus 1. I just replaced n by n plus 1 and I have this expansion. Replace x by 8. So you get 1 plus 8 whole to the power n plus 1 equals n plus 1 c0 plus n plus 1 c1 into 8 plus n plus 1 c2 into 8 square plus n plus 1 c3 into 8 cube plus and so on n plus 1 cn plus 1 8 to the power n plus 1. This is 9 to the power n plus 1. N plus 1 c0 is 1. N plus 1 c1 is n plus 1 into 8 plus n plus 1 c2 8 square n plus 1 c3 8 cube plus n plus 1 cn plus 1 8 to the power n plus 1. What is this? Try to deduce this. This is 1 plus 8n plus 8, which is equal to 8n plus 9. So this is equal to, I can write 9 to the power n plus 1 minus 8n minus 9 is equal to n plus 1 c2 8 square plus n plus 1 c3 8 cube plus and so on n plus 1 c n plus 1 8 to the power n plus 1. Minimum 8 square is definitely there beyond this term. Rest everything we have shifted to the left hand side. So I can take out 8 square common. I will be left with n plus 1 c2 plus n plus 1 c3 into 8 because 2 8s have already come out common. n plus 1 c n plus 1. From a to the power n plus 1, 2 have come out. So minus 2, n plus 1 minus 2, that is n minus 1. What is 8 square? 8 square is nothing but 64. This complete expression you know is an integer, or rather than that you can even say it is a natural number, because you know that NCRs, they always give natural number as values. Let me say this is equal to k, which belongs in the set of all naturals. So we have got 9 to the power n plus 1 minus 8n minus 9 is equals to 64k, where k belongs to set of naturals. Therefore, 9 to the power n plus 1 minus 8n minus 9 is divisible by 64. That means when you divide this expression by 64, you are getting k as the quotient and 0 as the remainder. Next question says what? Let's see. Find the 9th term in this expansion. Let's find the 9th term. We know the general form of finding the r plus 1th term. So here also we have to do exactly the same. Let's begin the computation of the 9th term in this particular expansion. So I am saying, if I need to find the 9th term, I know that what is the r plus 1th term in any expansion? R plus 1th term is n is 12, NCR x upon a to the power 12 minus r minus 3a by x square to the power r. Fine. If this is my r plus 1th term, I actually am seeking for the 9th term. That means 9th term can be written as t8 plus 1. Right, that means r is equals to 8, so this will be equal to 12c8 x upon a to the power 12 minus 8 minus 3a by x square to the power 8. NCR is same as NCN minus r, so 12c8 is same as 12c12 minus 8, that is 4. This is x to the power 12 minus 8 is 4 upon a to the power 4, minus 1 to the power 8 is 1, 3 to the power 8 into a to the power 8 upon x to the power 16, because this is 2 into 8, that is 16. This gives me 12c4, a to the power 8, a to the power 4, I am left with a to the power 4, x to the power 4, x to the power 16, I am left with x to the power minus 12, and this is 3 to the power 8. 9th term actually is, this is the constant term, that is the variable term. This is my complete 9th term. 12c4, x to the power minus 12, a to the power 4, 3 to the power 8. Clear? This happens to be my 9th term in the expansion of x upon a minus 3a by x square whole to the power 12. Moving on to the next question, we have find the coefficient of x6y cube in the expansion x plus 2y whole to the power 9. If I need to find the coefficient of x6y cube, I am actually saying there is a term in the expansion of x plus 2y whole to the power 9 which is containing the variable part as equal to x6y cube. That means I am saying let tr plus 1 be the term which contains x6y cube. Let tr plus 1 contain x6y cube. Then tr plus 1, what is the tr plus 1? That is r plus 1th term. N is equals to 9. NCR x to the power 9 minus r 2y to the power r. Simplify this. 9cr x to the power 9 minus r 2 to the power r y to the power r. This gives me 9cr 2 to the power r x to the power 9 minus r y to the power r. You can see this is the variable part sitting in the r plus 1th term. We are assuming that the variable part of r plus 1th term is x6y cube. This is going to be the coefficient of x6y cube only when 9 minus r is 6 and r is equals to 3. tr plus 1 is this, and tr plus 1 contains x6y cube. That means the variable part of tr plus 1 is x6y cube. That means this is x6y cube only when 9 minus r is 6 and power of y is 3. So that I get x6y cube in the r plus 1th term. But that can only happen when r is equal to 3. If r is coming out to be 3, this means r equals 3 means it is the fourth term which contains x6y cube. T4 contains x6y cube, where what is T4? T4 is nothing but T3 plus 1. What is T3 plus 1? It is 9C3, 2 to the power 3, x to the power 6, y to the power 3. What is TR plus 1? 9CR, 2 to the power r, x to the power 9 minus r, y to the power r. What is T3 plus 1? It is 9C3, 2 to the power 3, x to the power 9 minus 3, that is x to the power 6, y to the power 3, that is y cube. If you evaluate this, this comes out to be 672 x6y cube, and therefore coefficient of x6y cube comes out to be 672. Because this is the constant part, this is the variable part, its coefficient is actually the constant part sitting in the term, that is 672. Clear? Looking at the next question, we have find the term independent of x in the expansion that is given over here. That is what we need to compute. Let us find out. Term independent of x, let r plus 1th term be independent of x. Fine. In this expansion, what is r plus 1th term? It is 6cr 3 by 2x square to the power 6 minus r minus 1 by 3x to the power r. This is 6cr. You have 3 upon 2 whole to the power 6 minus r, x square to the power 6 minus r, minus 1 to the power r, 1 by 3 to the power r, 1 upon x to the power r. Collect everything related to x together. 6cr, 3 to the power 6 minus r, 2 to the power 6 minus r, minus 1 to the power r, 1 upon 3 to the power r. All these are constant terms. This contains x, this contains x. So you have x to the power 2 times 6 minus r upon x to the power r. Right? Eventually when you calculate, this comes out to be what? You can just calculate separately also. This is x to the power 12 minus 2r minus r, that is 12 minus 3r. So you can directly write x to the power 12 minus 3r. If r plus 1th term is this and it is independent of x, that means x to this particular power, the power of x is 0 in this term. If this term is independent of x, that means there is only constant part in this term, there is no variable part. That means x is not sitting with any positive power, the power of x has to be 0. So if r plus 1th term is independent of x and this is r plus 1th term, that means power of x is 0. That means 12 is equals to 3r, which means r is equals to 4. Question is find the term independent of x. We have found the term, it is actually t4 plus 1. Fifth term is independent of x in this expansion, and fifth term, that is t4 plus 1. Just in place of r you need to write 4. You will be getting 6c4, 3 to the power 6 minus 4, 2 to the power 6 minus 4, minus 1 to the power 4 is 1, 1 upon 3 to the power 4, and x to the power 12 minus 3 into 4 is 12, x to the power 0, because obviously it has to be 0 for r equals 4, right? This is what is my fifth term, which is independent of x. This happens to be 6c4 is what? 6 factorial upon 2 factorial, or I should write 6 factorial upon 4 factorial into 2 factorial. This is 6 into 5 into 4 factorial. This cancels out. 30 upon 2 is 15. into 1 upon 2 square is 4 and 3 square is 9. So it is 15 upon 36, 5 upon 12. 5 upon 12 is the very fifth term in this expansion, and clearly you can see it is not having any positive variable, any positive power of x sitting with itself. Okay. Next question we have, show that the coefficient in the middle term, coefficient of the middle term in this expansion is equal to the sum of the coefficients of the two middle terms in the other expansion. If I talk about the first expansion, I have 1 plus x whole to the power 2n, and 2n is even. Therefore, over here if I talk about the middle term, it is 2n by 2 plus 1th term. This is the middle term, that is n plus 1th term, n plus 1th term, that is Tn plus 1. What is the n plus 1th term? R is equal to n over here. This is your index. This is 2n Cn, 1 to the power 2n minus n, x to the power n. If this is your middle term, coefficient of middle term is coming out to be 2n Cn. This is the coefficient. Next we have 1 plus x to the power 2n minus 1. If 2n is even, 2n minus 1 is odd. We also have 1 plus x to the power 2n minus 1, and 2n minus 1 is odd. Therefore, we are going to have two middle terms. Middle terms will be what? Middle terms will be what? 2n minus 1 plus 1 by 2 and 2n minus 1 plus 3 by 2. These two terms are my middle terms. That is 2n by 2, that is nth, and 2n plus 2 by 2, that is n plus 1th. Fine. Nth term can be written as n minus 1 plus 1, because I have to write it in the form of r plus 1, right? And Tn plus 1. What is this? Now here the index is 2n minus 1. C n minus 1, 1 to the power this minus this, x to the power n minus 1. And what is the n plus 1th term? 2n minus 1 Cn x to the power n. Therefore, coefficients are 2n minus 1 Cn minus 1 and 2n minus 1 Cn. Question is saying that when you add these two coefficients, you actually should get this coefficient. Is that true? 2n minus 1 Cn minus 1 plus 2n minus 1 Cn. If you can recall the formula, NCr plus NCr minus 1 is n plus 1 Cr. If this is something that you can recall, very, very nice. NCr, it is like, you know, NCr and NCr minus 1. This is 1 less than n. This is equal to n plus 1, that is 2n minus 1 plus 1 Cr. This is playing the role of n, this is playing the role of r. So, NCr plus NCr minus 1 is n plus 1 Cr, that is 2n Cn. And 2n Cn is what is written over here. So, it is true that when I am adding these two coefficients of the two middle terms in this expansion, I am getting the coefficient of the middle term of this expansion. Clear? Next question is, the sum of the coefficients of the first three terms in this expansion is 59. Find the term of this expansion containing x cube. So, there are two questions basically. First of all, I need to decode what m is, and with the help of m then find out which is that term which contains x cube within itself. So if I talk about x minus 3 by x square whole to the power m, I just need to find out 3 terms because that is what are required over here. This will be mc0 x to the power m minus 0 minus 3 upon x square to the power 0, mc1 x to the power m minus 1 minus 3 by x square to the power 1 plus mc2 x to the power m minus 2 minus 3 by x square to the power 2 and so on. What is the coefficient here? It is just mc0. This is the coefficient. Here it is minus 3 into mc1. This is the coefficient. Rest everything is going to give you some power of x. So coefficient, that means the constant term involved in the term. This is mc2. Minus 3 square is 9. This is your coefficient. Rest expression is going to give you some power of x. So if these are your 3 terms, we are given sum of the coefficients of first 3 terms. mc0 minus 3 mc1 plus 9 mc2. This is given to be 559. mc0 is 1 minus 3m plus 9m into m minus 1 by 2, because mc2 is what? What is mc2? It is m factorial upon 2 factorial into m minus 2 factorial. This is m minus 1, m minus 2 factorial. So you eventually get m minus 1 by 2. This is equal to 559. Clearly you can see when you will be solving this, you will be getting a quadratic equation in m, and when that would be solved, you would get m is equals to 12. When 12 is obtained, you have evaluated m. Now the next question is find out the term which contains x cube. I am saying let r plus 1th term contain x cube, where what is your r plus 1th term? It is now m is come out to be 12, so your index is obtained as 12. R plus 1th term will be 12 cr x to the power 12 minus r minus 3 by x square whole to the power r. Let's just resolve this. This is 12 cr and then you have minus 3 to the power r, x to the power 12 minus r minus 2r. Because this is 2r, it is going to go above, it will be minus 2r. So this is complete term involving x. If r plus 1th term contains x cube, it can contain x cube only when this thing is 3. That is 12 minus r minus 2r is 3. So 12 minus 3r is 3. That means 9 equals 3r, r equals 3. If r is equal to 3, that means 4th term, that is t3 plus 1, that is t4, contains x cube. And what is your 4th term? t4 will be 12c3 minus 3 to the power 3 x to the power 3, because for r equals 3, this is equal to 3. So x to the power 3, what is its very coefficient? 12c3 minus 3 to the power 3. When r is 3, that means the term is 4th term. You can very easily evaluate this. This happens to be your 4th term which contains x cube. Talking about the next question, we have in the binomial expansion of 1 plus x whole to the power n, the coefficients of 5th, 6th and 7th terms are in AP. Find all values of n for which this can happen. Okay, so I basically need to focus upon the 5th, 6th and 7th term of the expansion. The expansion is pretty nice. It is 1 plus x whole to the power n. I know it is nc0 plus nc1, nc2, this is nc1x plus nc2x square plus nc3x cube, nc4x to the power 4 plus nc5x to the power 5 plus NC 6x to the power 6, NC 7x to the power 7, and so on. 5th, 6th and 7th term. First term, second term, third term, fourth term, 5th term, 6th term, 7th term. I am saying T5, T6, T7 are in AP. That means twice of term 6 is term 5 plus term 7. That means twice of term 6 is, the coefficients are actually in AP. Not the terms, but actually the coefficients are in AP. What are the coefficient of the 5th, 6th and 7th term? NC4, NC5, NC6. They are in AP. That means twice of NC5 is equal to NC4 plus NC6. So 2 is equal to NC4 upon NC5 plus NC6 upon again NC5. You should know that NCR upon NCR minus 1 was equal to N minus R plus 1 whole upon R. Very, very important property. So NCR upon NCR minus 1, this is equal to what? Leave this. NC6 upon NC6 minus 1 is N minus 6 plus 1. It is N minus 6 plus 1 whole upon 6. NC6 upon NC6 minus 1 is N minus 6 plus 1 whole upon 6. This is not in the form of NCR upon NCR minus 1. In fact, this is opposite of it. This is reciprocal of it. So if I talk about NC5 upon NC4, now it is NCR upon NCR minus 1. It is N minus R plus 1 whole upon R, which is N minus 4 upon 5. So its reciprocal will be, its reciprocal 5 upon N minus 4. Right? It will be 5 upon N minus 4. N minus 6 plus 1 is N minus 5. Now just evaluate, this is equal to 6 into 5 is 30 plus N minus 4 into N minus 5 whole upon 6 into N minus 4. Now next is what? We have 30 minus, or I should write plus n square minus 5n minus 4n plus 20 whole upon 6n minus 24. This is equal to actually 2. Right? This gives you what? 30 plus 20 is 50 plus n square minus 9n equals 6 2s are 12n, 24 into 2 is 48. 50 plus 48 is 98 plus n square minus 9 minus 12 is minus 21n equals 0. So n square minus 21n plus 98 is 0. So you get n square minus 7n minus 14n plus 98 is 0. Minus 7 minus 14 is minus 21 and minus 7 into minus 14 is plus 98. This is n minus 7 minus 14, n minus 7. You eventually get n minus 7, n minus 14, which implies n is equal to 7 comma 14. These are the possible values of n, which if you place over here, the coefficient of 5th, 6th and 7th term in the expansion of 1 plus x whole to the power n are going to come out to be in AP. That completes our discussion over the questions. That's it from my side. Thank you.